All right, class, this video is to go through the first 3 questions of the conditional probability worksheet. So let's talk about the technique that you'll want to use on these problems. So the first thing that we want to remember is the formula for conditional probability. So I'm going to go ahead and paste that in here. All right, so we've got our formulas here. These are going to be extremely helpful in a lot of these questions. For number 1, let's go ahead and start looking at it. It says the probability a student takes the bus to school is 0.8. The probability the student is late for school is 0.2. And finally, the probability a student takes a bus and is late for school is 0.1. What is the probability that the student took the bus given that they are late for school? So this given that statement, that's what we're looking for when we're working these questions. So let's go ahead and start with number 1. There's a recommendation that I have for you for really all of these questions. And at the top of the worksheet, it says to show work. So ideally, you're on a blank sheet of paper doing this work. If you printed this sheet off, that's fine, but you don't have enough work in between these spaces between the problems to do what you need. And I don't want just answers. I need to see actually you writing the work, using the formulas appropriately, and then hopefully you'll construct some two-way tables. So let's go ahead and make a two-way table for this situation. Number 1 is actually sort of on this sheet, I'd say the easiest problem. But let's just go ahead and give you a mindset for working these. Let's start with making a two-way table. So I'm gonna go ahead and build mine. All right, so there's my two-way table. And let's go ahead and name the events. First off, we have probability they ride the bus. So I'm gonna put B for bus. And you'll typically, this is so helpful to put that bus complement, just not that event. It's going to be very helpful for organizing a lot of these problems. Next, the probability that a student will be late for school, so we're going to say L is late, is 0.2. So we have late and not late. So let's go ahead and fill this out with the information we know. So probability they take the bus is 0.8. So this 0.8 here should be going into our, this is totals, right? Total, those go on the margins here. All right, so total we put here, so 0.8. All right, then it says probability they're late is 0.2. And then lastly, probability they take the bus and they are late for school is 0.1. So we have to know what that and means. It means the intersection, which is right here. All right, and from there we can start filling in the information we need. So we know this is 0.7. This is 0.1 right here. And then the key information that we need is that the total has to add up to 100%. So we put 0.1 here. And that helps us fill in the rest of this. So we know this is 0.8. This is 0.2. And that means this has to be 0.1. All right, perfect. So what is the probability that a student took the bus given that they are late for school? So we're going to write this up in symbols. What is the probability that they took the bus? So took the bus given that. So took the bus given that they are late for school. Now there's a lot of ways to think about this, but I do want you guys to practice with this formula. We have our formula over here. So we're going to use that. We write this like this. Always in the denominator is this right one. So this is probability of late divided by, we have the intersection of the events, probability of bus and late. Okay, so the decimals, what we look for are the intersections, so 0.1 over 0.2 is probability of late. Okay. And that's going to equal, when you divide that, so you'll want to get decimals for these, 0.5. That's what I'm going to be looking for. And you can't even see because I have this hidden. There it is. So 0.1 over 0.5. So 0.1 went up top, 0.2 on the bottom. I got all of that from my chart up here. So that's how you're working that question. Again, that's the easiest example. And honestly, you didn't need the two-way table for it, but I want us to get into the habit of doing that. Okay. Let's look at number 2, and I'll work number 2 right here. Okay, number 2. A teacher will have either tea or coffee for breakfast. The odds are 50-50. The teacher will also choose to have toast with or without butter. The odds are also 50-50. The probability that the teacher will have tea and buttered toast is 0.1. What is the probability the teacher will have tea given that the teacher has unbuttered toast? So let's go ahead and build. You're going to want a two-way table for this one, trust me. There's a lot to think about. Two-way tables just make all of these a lot easier. So let's start with that. I'm going to go ahead and construct mine. So I've built the framework of my table. Let's go ahead and write the event. So on this, it seems like the main event that we want is tea and toast being buttered or not. So I'm going to say tea or not tea. Seems okay. And then you have butter, not butter. Why am I putting a T? Butter. Okay, so we've got that. Now, we know that this is going to be in decimals, but it says 50-50, and it says, but we have decimals, so 50% is the odds for tea or coffee. So I'm going to put 0.5, 0.5, that's 50-50. It says butter or without butter on their toast is also 50-50, so we put 0.5 and 0.5. Adds up to 1.0. Then it says tea and buttered toast, so that's here is 0.1. And now we can just fill in the rest of this. All right, so we have that done. Now let's answer the question. It says probability that the teacher will have tea, so tea given that the teacher had unbuttered toast. So we know the event that already happened was unbuttered. That's the B complement. So if I'm writing this up, given that is this line, we know that the toast is not buttered. And so over here, we're trying to say what's the probability they had tea, given that they had unbuttered toast. So T goes here. And again, the formula makes this so easy. So we're going to put the intersection of both. So tea and not buttered. And then probability of not buttered. So that's what we want. All right, so now we just need the values. Let me make sure that I don't block this with the screen again. Let me actually just go over. There we go. All right. So what values go here? Well, the intersection of tea and not buttered. So we look for where they cross. So it's tea, not buttered, that's 0.4. So we're going to put 0.4 on the top. On the bottom, B complement. Well, what's the probability of not buttered toast? So that's 50%, so 0.5. And then we end up with, I think that's just going to be 0.8, but let's just double confirm. 0.4 divided by 0.5 is 0.8. This is going to be sort of the rhythm that you want with, let me move this, with all these questions. Number 3 is where it really starts to get a little bit wild, okay? So we're going to set this one up. And also, this is how you know that this worksheet comes from Great Britain. So let's read this one. It says, the probability that a randomly selected student will study maths, so and only in England do they call it maths, at high school. So it's 0.6. The probability a randomly selected student will study physics is the same. It is known that 70% of students study math. Let's underline this, or physics. So we have a different descriptor this time than what we saw. We've been getting a lot of these and statements. Look at number 2 up there. We've seen a lot of ands. Now what does or mean? That's all going to be important for this. We have to remember all these little rules and what these statements mean. Let me construct our two-way table. So on this one, it's tempting to put math and then say not math is the physics part, but that's not how this one's structured. How we need to be thinking about this one is maths, not maths, physics, not physics. Okay, so it says the probability that they're going to study maths is 0.6. So we put 0.6 in our total column. And it says physics is the same. So we put 0.6 under physics. And we already know that this is going to be 1 right here. All right, so this is going to be 0.4. This is going to be 0.4. And here's where the challenge really comes in. And this is where I'm going to leave you on this. Okay, I'm not going to finish this problem. Okay, there is a difference between this the 70%, 0.7, with this or and this and. First off, it doesn't make sense for us to put a 0.7 here, right? Because it's impossible for it to add to get 0.6. It's too much. So that isn't possible. Okay. I will set up the question for you here, which is, what is the probability that a student who studies physics, so here we also see a different language. It's no longer saying given that, it's saying who studies physics. That is another way of phrasing given that right there. Also studies math to the nearest percent. So we want probability, and this is number 3, by the way. Okay, probability, somebody who studies, we know that they study physics. So given that they study physics, what's the probability that they also study math? Okay, use the formula to help you on that. I'm leaving this blank. If you have questions, you just send me an email and I will answer those for you. But good luck. Good luck on this problem set.